And welcome to Database Design Chat number 15. Wow, it's been a few weeks since I've done one of these. Crazy stuff going on. But now let's get into it. I've titled this presentation Into the Unknown. If your parents of a certain age child, or perhaps a Disney fanatic like myself, hi Mickey, then you probably hear the song in your head right now, and I apologize for that. But it is really a good title because we're going to be talking about unknowns, also known as nulls. All right, so my name is Lewis Davidson, Dr. Sequel. You're on my channel, you probably know this. If you need any details about me, you want to know more, you want to contact me, just go to my link tree. That's where all my links are at. You can hit me up on social media, both Dr. Sequel at Dr. Sequel on Twitter, or a couple of Disney and Dollywood Twitter accounts I run, which I will also talk a lot about on my podcast, my podcast and vlogs for those. But today we want to talk about null. And while we've probably never seen anything quite this bad with nulls, we do know that everybody's probably seen some place where they've seen the word null replaced for their name or part of their name, or somewhere you've seen null where you didn't expect it to in the real world. And null is basically the root of most evil in computing, certainly database computing, because it doesn't behave like everything else does. It doesn't behave like we expect it to. In my informal poll of over 0 programmers, that's me, I'm at least the one. Null value errors are at least a third to half of all your programming errors, because you don't think about all the implications. It was even hard to write this presentation because I had to keep going back and remembering, oh yeah, that's one too. Let's talk about that. It is second only to not understanding the requirements, honestly. And that'd be the worst, right? I mean, we build something is not what the customer wants. But unknown and null really become the problem child. The lack of understanding what null really means is the root of this evil. Because if you don't know what it really means, you don't know what null stands for, then you're going to make more mistakes with it. It means unknown, but it means unknown in a more specific way than the word might belie. Because we all think if I don't know something and I take the opposite of unknown, that would be known. And that is absolutely not the case. Because while unknown does mean, maybe, perhaps, or undetermined for value, what we're looking at is unknown as a thing. You can't just say, I don't know who's playing baseball tomorrow, and just take the opposite of that and all of a sudden know all the answers. You still don't know what you don't know. If I don't know it, it's a value. Because I don't know that value, I take the opposite of that value. I don't know the opposite of that value. So it's not really unknown in the same. I'm talking in circles. And that is really what happens when you talk about nulls. If it helps, you can visualize this as a value that's simultaneously every value. That's not really technically correct, but it is correct in that when I say something is null, I'm saying that I don't know its value, but it probably has a value. But I don't know. Right? I'm not saying null is a thing that you can compare other things to, because you can't even compare it to itself, because two values of null are different just by their nature. So you don't know which of these values you're comparing to. So it's always unknown if values match. So that unknown value, that's the thing. I don't know if that value, if I have 1 equals 1, I know that's true. If I have 1 equals 2, I know that's not true. If I have 1 equals some value I don't know, then it's not known, it's unknown. And how that unknown gets propagated in expressions is where the fun part comes with nulls. It absolutely does not mean nothing. Okay, that's not the definition of null, because I can compare nothing to nothing. Now, sometimes it's treated as nothing. For example, I use it as a foreign key. Then we don't have a foreign key reference. We may use a null value, and then that null doesn't compare. Okay, that's a way it's used to mean nothing, but it's dangerous. It's dangerous when you start thinking about all the mathematics that you're going to have to do with this. All the data types in your relational database support null. Bit used to, not in a long time ago, but it has for many, many, many years. I know some people are still out there running SQL Server 2000, 7.0 probably somewhere, but every one of this version of SQL Server for the past 15 years at least supported bit with null. And so every value can say, I don't know this value yet. Think of it as when you're filling in a form, a piece of paper, and it has, what is the date? And before you put something in that column, that field on that piece of paper, that value is unknown. If you skip past it later and you still leave it blank, it's not that you said you didn't fill in this date ever. You filled in this date at some value, some date in time throughout eternity. It just means you didn't put it in there. And so that value is unknown. So nobody needs to figure it out. Things like first name, last name, middle name. Often you don't know the person's middle name, so you can use null for that. If they don't have a middle name, they don't have a first name, things get more tricky. You may want to come up with a way to say, stop asking them for it. I'll talk about that in a few minutes. I'll dig in deeper on the constraint questions and how constraints work later. And I've got a little bit of a teaser on that later in this session. So how do you compare something to unknown? Very, very carefully. Comparing any value to a null returns a Boolean null. So if I compare 1 to 1, that returns a Boolean true. If I compare 1 to 2, that returns a Boolean false. If I compare 1 to null, then that's null, that's unknown. All right, so comparing any null value returns a Boolean null. A Boolean null is different than a Boolean true or Boolean false. It could be either one. So don't trust it to be the value. So if null equals null, or if Bob equals null, alternate if null. So it really means if I'm not sure what the value is, whether it's true or false, it really means you don't know. So don't treat it as truth. So it's important to know if you're looking for truth or non-false in your expressions. For example, when you do a join clause and you have a null value and it joins, it's going to fail, and you might think it's false. So you might join one row with another, and one row has a null value for the column value. It doesn't fail, it just isn't true. Some things look for non-false answers. For example, constraints work this way. If you have a null value in your column and your check constraint doesn't check for nulls, then it's totally fine. So I might say value equals Bob. Well, if value is nullable, what my check constraint is really saying is, as long as I don't get a false answer, so Bob can't equal John, that's a failure. If I say Bob and null, so the null value, the column allows nulls, the expression allows nulls, it's okay. So that's looking for a non-false answer. And I will look deeper into that when I actually cover constraints, but there's a big difference between truth and false and unknown and what you're looking for, what it matters to you. When you start to do math and concatenation, since a value is unknown, but still a value, doing things like adding values to an unknown value are going to end up with an unknown value. So if I have $50, somebody hands me $50 and they don't know how much money I have. I don't know how much money I have in my pocket. I don't know how much money I have, so it's unknown. And you might think, well, you can be assured that's a positive number, right? Not necessarily. I could have a negative amount of money in my pocket. I could have an IOU. So I still don't know how much it is. I don't know anything about the magnitude, anything of this value. So have to be careful with that. When I do concatenation with a null, again, not using the concat function, which actually will handle nulls for you. If I concatenate the quote value with null and then add is null, I'm going to get back a null value because I don't know what null is. I can't put those together. It's tricky, right? It's really confusing. It's not usually so open out in the open, just like, all programming problems. You've got 3 lines of code. It's easy to find the problem. You got 30, 40, 300, gets a little more complicated. Negation is really the most confusing part. So let's say I have not 1 equals null. So, throw out your thoughts that 1 equals null is going to be false. That's null. Not null is, again, null. So I don't know what the value is. I don't know if it's true or false. I don't know anything about it. I have to call it null. So if you start negating this a lot, and I do not null, still null. So no matter how much you do this, it's still going to be null because you're not looking, and then how you deal with that will be based on whether you're looking for truth or false. Most of the time you're looking for truth. Null is not truth. I mean, you have a big where clause with 10, 12, 15 conditions that can get troublesome. It's really just super important to realize a null means a value you don't know. I've harped on that enough. And as a Boolean, it means true or false. And the opposite of true or false is really the opposite of all the values in there. It might be false or true or false or true, but those are, equally the same values. So that's, it's the thing. A little bit about how null comparisons work. If you want to show the column is null, there's a function is null. So it's true where the column value is true, is null. My goodness. True where the column value is null and false otherwise. And there's the opposite of that. You can say where it's not null and it's false where the column value is null and true otherwise. Simple. Where it gets more interesting is when you start doing comparisons. Null compared to anything else with like an equality operator will just return null. But where it gets tricky is what about like an in condition? What about it like an or? And in is really an or for every single value in the set, right? As how it processes. So if we say we're column in 1, 2, 3, null, this is true wherever any value is 1, 2, or 3. And then it is null for any other value. This is because when you're looking for the value, it checks 1, no, false, 2, false, 3, false, 4, null, returns null. Okay. If you didn't have a null there, it'd be true or false. This is generally okay because when we're doing a where clause, our goal is typically to find truth. So, well, not typically. So, the where clause always evaluates for truth. So it's not generally a big problem. Where it gets complicated is where you get a situation like this. So if you have where column not in a set, and that set includes null, there are 2 things that can come out with this. False, if the value is 1, 2, or 3, it sees for sure that this value is in the set. It's null in all other cases for the same exact reason that we talked about in the in clause. But since we're looking for truth in a where clause, nothing gets returned from this value. Now, I had a really hard time making this slide because I kept getting it wrong. And I had to prove it to myself. So let's go over and look at this in Management Studio. Let's write some queries that prove this. Because one of the things you can't do, other than find the window you're looking for, one of the things you can't do is you can't say select value equals 1, print Boolean expression. It doesn't work that way. You can't print a Boolean expression. I'll prove that. See, print. Don't type in a demo. Print 1 equals 1. It fails. Incorrect syntax. We don't get a Boolean. So we have to use if expressions, things like that to see what's happening. So I set up this little test and I've got declare value equals 1, int equals 1. If value equals 1, select true 1. If not value equals 1, select true 2. I run this and obviously we're going to get true 1 because value equals 1. If I change this to value equals 2, I'm going to get true 2. Okay, so that's simple. What if it's a null value? If it's null value, I want to check a couple things. I want to check to see if it's 1. That's true 1. I want to see if the opposite of that is true. And I want to see if the opposite of that is true. Obviously, you know what should be happening if you've been listening to the previous part of the presentation. I get no output whatsoever. None of these are true. Okay, and this is simple. This is very obvious kinds of questions that we deal with when we're dealing with nulls. But where it gets even more complicated, okay, maybe this isn't obvious. That's tripped up more than one person. But what gets a little more complicated is when you start doing these things like n. And n's the one that hurts everybody the most, typically, other than that not thing, right? That's the not is probably the number one thing, because you not something that looks like false in your mind, and it doesn't come out as false. It's true. You're like, what the heck just happened? But here we go. So the value is 1. If I say the value is not in 1, 2, 3 null, that's going to be true 1. If not, check value in not 1, 2, 3 null. Okay. If I do this, I should get false. So it's false that this value is not in it because it sees the value. This is the one that tripped me up a lot, because it goes 1 is 1, 1. Yes. Not false. Done. All the rest of them are inconsequential to the thing, because truth, when you're Boolean like this and it's true or true, it's or. One true is done. Its value is 4 though. This is where it gets interesting. Is it 1? Is it 2? Is it 3? Is it null? Here we're going to get nothing, because 4 is not in 1, 2, and 3, and you can't compare it to null, so it's null. And here we not that. We still get nothing. And then now let's do one more thing. What if it's null? Is null not in 1, 2, 3 null? Of course not, right? This is obviously going to return no value. And I have to admit, as I watched it, I was like, is it really going to return nothing? Let's see. Even though I knew it was going to, because I've tried this before. All right, so let's continue. So we talked about, all these conditions of what if it's an or. Well, I'll look at the true tables really quick. Obviously, we've already talked about not. So not true is false, not unknown is unknown, not false is true. But where things get interesting is when we start doing ors and ands. So true and true is true. True or true is true. True and false is false. True or false is true. Well, now this is where it gets interesting. True and unknown is unknown. Unknown is, again, not true. Usually in a query, that's going to cause you to not return the row. But true or unknown is true. So that's where I was saying a second ago, where the in clause, you might have other ors that allow that. And then um, false or unknown is unknown. So if unknown is okay, you may end up with things that are okay. This is where things like check constraints. If you're looking for false, not truth, you may end up okay because you do an or and you end up with a null condition. So if null is so bad, why not stop using it? Well, the alternatives just suck. I can't say it any clearer than that. Because like a lot of people come up with what's known as a surrogate null value. Like if you have a domain of positive integers, you might say -1. But if you do something else where you need that -1, then it gets messy because the next time you start to write queries, everybody's using -1 to mean null. It actually is allowed in this set. So you have to make it -12. And how do you come up with a value that absolutely will not be in most of your sets to compare to that you would want to put in there and then make it look like real data? It gets complicated. So I hate that kind of way of thinking. I actually do use that in my data warehouses for surrogate keys. I may have a negative and zero values to negative or zero value to replace that unknown value. But that's in a data warehouse where the output is query. I don't like putting a none value in my domains in my customer table. I don't want to have a row that says no customer in the customer table because there actually could be a customer named the no customer. That's why there's a best way trucking, right? Which way do you want to use? I want to use the best way. I'll give you the best ways number then. Tricky things marketers do. So another thing that people try to do is to make a new table. So you might have person and person ID and last name. You can say everybody's required to have a last name in your database, but they're optional to have a first name. So we'll make another table called person first name, person ID, first name. And if you have a first name, you fill in this row. You've got a foreign key to the person table. So the person table has to come first. All is dandy, right? Except this is a pain to use. And B, when you go to use this table, you're going to have to do an outer join between person and person first name. And you're going to end up with nulls anyways. And there's no special value of null that says, I came from a query. I came from the table. There are some grouping things you can do when you get nulls when you're doing grouping sets, but that's completely different. Here, you don't get that in an outer join. I don't know that the null from an outer join is the same as is any different than the null from a anything else. Sometimes you may actually need to indicate that you don't know that you don't know. Like somebody might have only a last name or only one name, and you put that in the last name and say they don't have a first name. And we're not going to keep asking them for their first name. And I know they don't have a first name. I add a column that says, yes, no first name. So fine and dandy there. So just really annoying ideas. So when null has a meaning when null means an unknown value that could be anything, it's great. It actually works really well. It's just saying it is a nothing value, a blank value where it gets complicated. And then handling these missing values in a standard way is just something you're going to do whether you're doing it with one table or 10 tables, whether you're using outer joins or it's in the table. You're going to have to deal with it one way or another. So it's what we have, and it works well enough. All right, so I've told you a little bit about null, showed you a little bit about how it works. It's a pain, but it is what it is. And again, I'll say it again, correctness starts with proper structure, and null is part of that. Normalizing up to third normal form, didn't change that. Nulls are necessary to keep a database simple enough to make it work without having, bunches of tables or phony values in the table. I've never worked with a database that didn't have some null values, either through the column values or joins. There's going to be null values you deal with. So yeah, as long as you understand and you respect what it means when you're doing comparisons, it's not that big of a deal. It isn't, but it does cause a lot of errors because we don't test well enough sometimes with null values in all the places nulls could go. Because a lot of columns will be like, there's only one null value in the whole entire table, maybe two, maybe three, and it's a million row table, but it still needs to be tested because that one null, it may not even show up in any of your test data. In your real data, you may not see that until way too late, and then that's where problems start coming. And that is actually we'll talk someday about testing and the real problem with testing being that, you don't test, you can't test everything. There's way too many permutations of things that can occur. So you obviously test the stuff that typically happens. Things that are null are a good example where, you have first name and last name and you don't ever really test what happens if a person doesn't have a first name. All right. These things are longer than I very much expect. If you have any questions, throw in your comments on this YouTube video, email me, message me on Twitter, contact me anywhere you find on DRSQL or Linktree. I would love to add an episode to answer people's questions. That would be the greatest thing in my life. So make that happen for me, okay? This has been fun. I love talking about the worst topic in databases. Nulls. Triggers, nulls. Those are two of the most disliked topics. I like talking about both of them. I like them both. So I'll see you next time when I'll be talking about something else. Bye-bye. Five, four, 5, 4, 3,